Record. Got it. Perfect. All right then. And I feel sorry, with one more person in the waiting room. Excellent. So with that, yes, let's get started. So first of all, I wanted to try a little bit of an icebreaker, but when I got into the Zoom meeting, I figured I actually cannot make polls. So we're gonna do it a little bit more of a mental exercise here. If you guys are okay with that. So when I was in my master's student, I did all my masters throughout the pandemic. So one time, one of my professors walked into the Zoom room and just started talking about how she met a student in person and was not expecting to be that tall, which was very surprising. And at the moment, I guess we all realized, like through Zoom, you don't actually know how tall someone is. So I wanted to try to see, first of all, if we could gather here a bit of data regarding the height in this room. But unfortunately, we are not able to do polls as far as I can tell. But so for now, let's work with me here for a bit. So what I was expecting is to see essentially something like this. You would get some sort of overall normal distribution is going to be a relatively nice and easy categorizable data. We expect people to be in height. And this, like, once you add maybe a bit of information sex at birth, or you cross it through age, you can start getting some, you would be able to very easily start to get some correlations between data by looking at all these different groupings and just getting a really nice data set overall that you can start using for further analysis with other different variables. And that is really nice and useful. And unfortunately, that is not always the case. Sometimes we get a data set that is an absolute mess. It's just open text fields everywhere. It's just paragraphs and paragraphs and paragraphs. And you're supposed to get that information, and that is not easy. So for instance, I wanted to do an example here. I'm a huge nerd, big disclosure here. I guess not surprising for a person who does statistics for a living, but so I play Dungeons and Dragons, and recently there was this huge drama, and the community was very angry with the company. So the company started creating this survey for people to voice their opinion. And of course, they had an open text field at the end. And some entries, because people share their entries publicly, look like this. So I was just imagining what it is to be that person working for Wizards of the Coast and receiving this billions of paragraphs that look like this. And then what do you do? What are you supposed to do with the data? How can we transform this very passionate piece of text into something that is actually usable and that can be analyzed and then delivered? So with that, let's look at one of the options, one of the tools that we have at our disposal, which is regular expressions. So let's talk a little bit about what regular expressions are, just to begin with. So first of all, one more person coming in, give me 1 second. Okay. So what is regular expressions, or by short, regex? Regex, I actually never thought about how people pronounce this. I probably should have asked that earlier. We're gonna go with regex for now, and hopefully that's right. So regex at its core is when you create a sequence of characters or a string, and then you use that string to determine, which is determining a pattern that you can use to search for a specific string in a different piece of text. So in a little bit, hopefully less convoluted explanation, you create a pattern string that then you can use to search for that pattern in a target string. So the benefit of this kind of regex is that you can create flexible and concise patterns that will make your code very efficient to find through very large pieces of target strings and be able to see if you can identify a match or not. Now, what Perl regular expressions are, essentially, Perl is just a specific syntax in which regular expressions are used. Just like you have SQL as a language, and then you have very different kind of like languages or interfaces that use SQL. For instance, Postgres, same thing. You have regular expressions, and you have different languages, or I guess interfaces that use regular expressions, such as Perl. So because we're going to be working generally in SAS here, we're going to be sticking to Perl regular expressions, which is the ones that to be honest, the ones that I'm used to working with SAS. But for the most part, the things that we're going to be overviewing today, although they are going to be in SAS, they can be taken in other languages such as SQL and R, etc. So let's go through that. So what I have prepared here is going to be a quick worksheet in SAS code that we can all go through. We can all go through together, and then we can start going through a couple of specific cases and some that we might be able to use in those kinds of scenarios. So what I'm going to do is I am going to exit presentation mode very quickly, just so I can access here the chat easily. And I am going to share the code here. Also, if you do have the OneDrive file, which I highly recommend, where we have uploaded all the files for the presentations for this week, you can also find the presentation and the code there. So I will be putting here, and thank you, Lala, for posting that link. In the meanwhile, just in case, oh, no, that's not what I wanted to do. What is happening? We're going to be posting his here. We're going to send it. And in case you don't have SAS or you want to work, for some reason sometimes you have issues opening those files for SAS programs. I think sometimes when using the SAS Online software, it might be complicated. I have also attached here the text version of that same file. It's going to be the exact same information. It's going to be one in text format versus SAS. All right, so with that, let's get started. There we go. So I'm going to go ahead and share my screen again. And thank you, Lala, for sharing that link. I really appreciate that. Share screen, share this one, and here it is. Perfect. So as always, we all code in very different ways, and we all have our own little systems that we use. For me, I like to put everything in brackets. So what I like to do, if you have a long keyword with its own number pad, you can do Control-Alt- on the number pad, collapse everything, and then you can just go through these little proc symbols here that are really useless. I just use them as separators, so we can start collapsing and opening different things as needed. So a little bit of organization in my code. Please don't judge. Hopefully, also a quick question. Is this, and maybe Lala, you can answer this, is a good amount of zoom? Should I try to figure out a way to increase the zoom on this image?
I think it's pretty good unless someone objects.
You have 5 more seconds for objections. All right, perfect. Perfect. All right. So first of all, what it did, I do have all the tables just added in here. So what we can do, we're just gonna run all these tables very quickly. There's nothing too crazy, just a couple nice and easy tables to be used. Excellent. So with that, now we are gonna start going through a couple exercises. So it's gonna open up the first exercise. All right, so PRX match. Let's look at kind of the general syntax of how this looks like. So in here, we have the PRX match function. What this function does is gonna look through a piece of target string, compare it to your pattern string, and is gonna give you the location of the first match that it finds in that string. So for instance, in this case, right now what we have as our match string is concert. And then what we have, sorry, as a pattern string. And what we have as our target string is what kind of concert only costs 45 cents, a 50-cent concert featuring Nickelback. Please bear with me. There's going to be a lot of these puns and jokes. Hopefully that's okay with everyone. I try not to take my code too seriously. Perfect. So let's look at what is happening in this syntax. Let's open up a little bit of this function and see what is happening. So PRX match is a function that searches for a pattern string and returns the position of the first match. Important because it's going to return only the first match that it finds. After it finds something, it will not keep on searching. It's an important thing to distinguish. Then when you're looking at PRX syntax, you're going to start with a parentheses. Then everything is inside that parentheses is going to be in quotation text. So in this case, we're going to have the first, then we're going to do a / which indicates the start, first of all, of the pattern that we're going to be searching for. And then the second / is going to indicate the end of the pattern that we're looking for. We close those quotations, we add a comma, and then after that comma, we're going to be putting the string, the target string that we're going to be using. In this case, we use an actual string as a target. However, you can also replace this with a variable, which we'll be doing soon. That's just going to be a lot easier going forward. So let's start running this very quickly, and then we'll go back and forth between the next operations that we're doing. So let's do that, and then let's print the output. So in here we have what kind of concert. So the first thing is, remember, the test variable that we created is going to be the position of the word concert when it matches. So in this case, it is going to be here. These are 13 characters, and that C in concert is a 14th line, the 14th input in that string. And that is why it is giving you that match with the concert pattern that we're looking for. So what are all these other things that we're also looking for? And what else can we do other than just look for a simple pattern? Okay. So regex can be very flexible. So for instance, instead of me just giving here a full word, I can give it an option to look for. So in this case, I gave it here, open in brackets, I enter any character that I want to match. So in this brackets, I want to match the A, the B, or the C character. And if any of those are found in the match, it will locate it. So for instance, in this case, there's a bracket test that we mentioned before. It is the third character because it was looking through this whole string and it was looking for A, B, or C. So the first one was not, the second one was not, but the third was an A. So because of that, we got returned a number 3, which is the third position in that string. So that is something that you can do. You can give it multiple options. Then you can do the opposite. You can give it to find any character except those inside of those brackets. And that's why I use the not for. So in here, we use the not, and we're gonna ask it to search not for W, not for H, not for A, but anything else is fair game. So it will match anything else that is not those 3. So we go to our results. We see that what starts with WHA, what a coincidence. And then on the 4th character, we have a T that does not match with those characters. So it does fulfill this quality. So that's why the PRX match with that pattern. It found the T and it returned the position of that T over here. 4. Now, the next thing, also, I forgot to mention at the very beginning, if I'm ever going too quickly or if you have any questions at any given moment, please interrupt me. You can send a chat over here on the side, or over on the side, and I'll probably see it, I'm guessing, because it does give me a little bit of notification. Or you can just straight up just unmute and talk. I will not mind that whatsoever. So feel free to interrupt me with questions or comments, whatever. Perfect. So let's continue with these brackets. What else can we do with the brackets with PRX match? The next thing we can try to do is we can do a range. So if you give it a start to a range and an end to a range, it will search for anything inside that range, including the boundaries. So in this case, the pattern right now, it's any letter that is a lowercase b, c, d, or e. And any of those will give a positive match to the pattern. So let's look at the results again. And here we see that it was the 9th character. So we're looking for B, C, D, or E. And we see that it was not any of this 4. Then the 5th was a space. And then, there it is. That's the 9th character in the string that it matched. And then finally, for this kind of like basic introductory ones, we're going to be looking at the digits. So this is when we start getting a little bit fancy. So in general, if you just see this D right here, you're guessing, oh, it's probably looking for a D. But we added this backward slash, which indicates that this now has become a full meta character, which in the language of regex, it means something very particular. So this backward slash D, as indicated here, is looking to match for any digit character. In other words, is looking for 0 to 9 in a bracket range. That is something that we're going to be seeing very quickly here with regex, is that there's multiple ways to specify different things. So this /D or this bracket 0 to 9 mean the exact same thing, and I can write them in my pattern string, and they're in either way, and they would both match the exact same thing. They're literally synonyms in this scenario. So in this case, let's see, when are we going to match? So in this case, we're going to be matching this 45, specifically the 4. Excuse me, which is going to be the 33rd in that string. All right. So with that, let's start getting a bit more complex. Still get funky. But we're still going to be using PRX match. So some scenarios, you're going to have two words that are similar, but they're not the same. And you either want to match both of them, or you want to make sure that you're only matching one of them, even though they're very similar to each other. So what kind of tools can I use with regex in order to make sure that I'm making those differentiations when I need them, or making sure that I'm putting them together when I need to do that? So in this case, the first thing that we need to know and remember that is very important is that regex is case sensitive. So for instance, if we look over here in our data, let's look at the data strings that we're using. We see that we have 45 cents and then a 50-cent concert. So this cent and this cent are essentially the same. However, one is capitalized and the one is not. And regex will be sensitive to that. So let's go ahead and run that code down here and see how that looks like. So in here, first of all, what are we doing? So we said case test is going to be equal to the PRX match of cent, specifically capitalized, in the target. So in here, it is going to look for cent capitalized, and you see that the first line does not have a cent capitalized, and that's why the PRX match returned a 0. Well, down here on the second one, we do have cent capitalized, so returned a 6. Now, what can we do? If, for instance, if we do want to capture both of those. So there's multiple ways you can do this system, but the one that I use here is using operators at the end of your string. So in here, we have our match string, and then we have the boundaries set for that match string. And then we can add some operators at the end that do different things. In this specific case, the I operator makes it such that the search becomes non-case sensitive. So when we do the case test I, we'll see that it is matching both cents and cent, because it is now no longer case sensitive. So it doesn't care if it is capitalized or not. Another important character that we can look for is the wildcard character. So in this case, a wildcard is a period. So when you introduce a period into your string, it means that that period can be absolutely anything. It can be an uppercase C, it can be a lowercase c, or it could be a T, and you start looking for tent. All of those will be valid matches. Excuse me. Give me 1 second. Perfect. So all of those are going to be valid matches. So even though in this case the pattern is still case sensitive, because we use a wildcard for that C, it is matching either both of them. So that is why in the wildcard test, we see the exact same result that in the case test I, is because that C has now become anything. And if we had the word tent somewhere in here, or pent, it would also be matching that if it was before. Because remember, you just match once and you match the first thing you find. So that is a very useful tool to know, is that you can use that period to replace any character optionally. Now, on that note, what happens if you might or might not have a character and you're not sure? So for instance, in this case, going back over here and here we have the full word concert. But in many cases, we will have that there's spelling errors that happen, or especially in the medical field, there's a lot of abbreviations. So sometimes, the word concert might be abbreviated into the word concert. So regex allows you to be able to distinguish if a character is going to be the obligatory or optional. And to do that, we can use the asterisk and the question mark characters, which are going to be very similar but slightly different. So in this case, what you're feeding here as your pattern is, I'm looking for a C, and then I'm looking for an O. But I want the O to be optional. It can be there 0 times or 1 time. And if either of those matches, that is good for me. And then we're looking for an N, and then we're looking for a C, and then we're looking for an E. But again, the E is optional. And here's the difference. Well, the question mark can be 0 or 1 times. The asterisk can be there 0 or more times infinitely. So if, for instance, if instead of having concert, I had concert, because I put an asterisk in there, it will also match. So in this case, if we run, we'll see that it is giving me a match here for the optional test. We'll see that we have found concert on the 14th, but we also found concert on the 11th character. both of these were matched with a single piece of string, which is this one. So as you can see, this is when rejects can start to become a bit more concise because we're matching multiple things that were in theory different, but using one single piece of flexible string. So let's move on into other things that we can do. Another big one is using the bar. When using the bar symbol is giving you an or statement, essentially. You're giving the rejects, you're giving the pattern the option to choose between the word concert or concert. And both of those will match if found. So it really is as simple as just an or statement. So we go back here, we see the exact same result because we told them to either match the word concert or the abbreviation concert, and they're both valid matches. So that's where we gain the exact same result as we see with the optional test. And finally, you might ask at this moment, hey, but what happens if the word that I'm looking for has a period in it? The target that I'm looking for has a period or has a question mark, and I want to capture that. So that is where the backslash comes in again. The backslash not only is used to indicate a meta character out of a normal character, but it does the opposite as well. If you have a meta character like a question mark or a bar or a period, which is a wildcard, and you want to be able to find it, you can use the backslash to indicate that the symbol following that will no longer be a meta character, but will be the actual character. So in this case, we're looking for the word sense or the word Nickelback period and sense question mark. And because we use this backslash to indicate that this question mark and this period are not meta characters, but just normal pieces of string, we're able to find them. That sense is located here on the 36, while Nickelback period is located right here on the 27. All right, how are we feeling so far? Any questions at this moment? I'll use a 7-second rule, so I'll give 7 seconds for questions. Perfect. All right, so let's move on then. I'm going to take a sip of water though. Okay. So let's start looking into a bit more complicated things that we can start matching now that we can do with more complex queries of patterns. So in here, the first thing that we'll do is we'll look at a quantifier. In this case, the curly brackets. So when you have a character that you're looking for and you put curly brackets after it, you can indicate how many times you want that match to happen by doing a number in here and a number to replace the X and a number to replace the Y. In other words, in this case, I can say I'm going to be looking for a \d, which as we learned above, that's a number. So we're looking for any digit, and I want to look for that any digit twice. And specifically twice. If it's less than 2, it's not good enough. And if it's more than 2, then that is not a match. So in this case, that's what we did because we put X and Y to be the same. So if, for instance, if X was 2 and Y was 2, we could just replace it and put one single digit F specified down here. So let's run that and see how that looks. Did not run. Probably missed something. There it is. Okay. I'm gonna get this out of the way. So right now we're just gonna be focusing here on these first 2 lines at the beginning. So we're looking for 2 digits. Oh, I did run, it just didn't show. So we are looking, again, we're looking for 2 digits that are right next to each other. So in this case, we see how we found 45 cents here on the 33, 50 cents on the 3, but 1 was not found because it was only 1 digit. So it was not good enough. You need to have more than that. 22 was found, and then 33 was found as well, even though it has 3 digits. Why? Because what it found was it made a match with this first 33, ignoring the last 3. So that's why you also get a match there. All right. So let's move to the next example. So what if in this case, similarly, we're looking for a digit repeated between 1 and 3 times of that repetition. So in this scenario, we'll see it again now on the range test. Yes, range test. Now we're looking for a range between 1 and 3. So now this number 1, it is matched because the query, the pattern that we're looking for can be optionally one single digit. And then what happens if when we match that 333, we actually didn't want to match that. That one was an outlier and we didn't want it there. So we want it to be 2 digits and only 2 digits. That is when we can use this space meta character. So when we do /s, we're indicating that that character, for it to match, it needs to be a blank space, which can be a combination of things such as blank space, line break, tab, etc. Anything that is a blank space will be matched by a backward /s. So here, what we're doing is we are looking specifically for a blank space followed by a 2-digit number followed by a blank space. So if we go back here, we'll see now that the space test, it is not matching on the first because for the number 1 is not a 1-digit, is not a 2-digit number. It is not matching on the 333 because it is not surrounded by blank spaces, but it is matching the 22, the 50, and the 45. So good so far? All right, perfect. So finally, let's start doing a little bit more of practical information. How do we, now that we're able to match this, these target strings, what can we do with that? Because I mean, sometimes knowing the value in which the string is found can be useful, but it's not all the time. So what can we do with it? So in this case, what we're going to do, for instance, is let's say we want to create a variable in which we look for, out of all of these lines of text that we have here, which ones, excuse me, of them have a music artist in them. So we're going to be looking for music artists such as 50 Cent, Nickelback, Bad Bunny, and Shakira. So in this case, we'll see that, for instance, in the first line, we do not have an artist, so it was marked as 0. In this line, we do have an artist, and it was marked as 1, because it's not a music artist, so it's 0. Bad Bunny and Shakira, they're all music artists, so they're marked as 1. So what do we do? How do we get there? So we did an if statement, and just if this statement was true, essentially, if it was a non-zero statement, then I would ask for artists to become 1. Otherwise, I would ask artists to become 0. And just to make sure, because I wasn't sure if all these artists were capitalized or not capitalized, I just added the I operator at the end to make sure that my search was not case sensitive, and it was just a little more flexible to catch more things. And that's how we get here. For instance, Bad Bunny was not capitalized, so we were able to pick it up, even though our search was specifically for capitalized Bad Bunny. All right. So with that, I mean, to be honest, I can spend here all day talking. I'm sure you guys love my voice, but I figured we could try to make this a little bit more interesting. So I want it to be a bit more interactive. So what are we going to do here is I'm going to give you, let's say, 5 minutes. And if you have SAS open, you can go through this problem to try to solve this on your own, a little bit of a case scenario. And that way you can start practicing a little bit of these questions on your own. Do not open down here this 3 unless you want to spoil the solution. So let's first, okay, let's look at the problem together. So you have been hired by Children's Hospital of Colorado to be their lead data manager. The hospital is interested in finding the frequency of headache events among the patients who enter through the emergency room. However, all intake forms are captured in open text fields. Oh my God, how do people do this? How do they live like this? Making manually parsing through the data a time-consuming task. Your job is to use your rejects knowledge to identify the number of patients that have the term headache or any other related terms in their ER intake form. The data set intake is a small subset of all the ER intake form entries. It includes an ID variable for each patient, as well as a symptoms variable where each patient's symptoms are described. And you may also look into this table by running the print code below. I also make sure to add a small cheat sheet for you in case you want a quick reminder of what all of these characters do and how you can use them. So let's look at the data set very quickly. Let's look at it together. So this is what we have. So remember, we're trying to look for the word headache or any other similar alternative and see if we can identify how many of these patients have had an intake with a headache when they came through the ER. So again, I think we're gonna give this, let's say, 4 more minutes so you all can work through on your own. And if you have any questions, I'm gonna be just here having fun. All right. So that was a little bit less than the 4 minutes, but I think that should be a good amount of time. So let's start working with this together. So we're looking for the word headache, and it can be pulled in many different ways, especially on something as fast-paced as an ER. There's going to be a lot of shorthand. There's going to be a lot of typos. It's just part of the nature of the job. So let's start looking a little bit through this small sample of data and see what we can find so we can have an idea of what to make our pattern string look like. So let's say we have someone injured TikTok dance, right injury that doesn't have a headache, so we doesn't worry about we don't have to worry too much about that. We do have, for instance, a headache here, but immediately we see that it's separated by a space. So that might be something to keep a note of. Then we also have, for instance, over here, we have heartache. So we cannot just use the word ache to try to kind of like weasel our way out of this. We need to find a way to get the full word headache somewhere included, because otherwise we might pick up on these heartaches that we don't want to, unfortunately. Then what else do we have? We do have headache as one single word over here. We have headache capitalized down here. Tummies, abdominal ache. And then we also, I think I caught most of them. There might be one other in there. Oh, we have here a headache, but it's just HD ache. So that might be another abbreviation that we might be stumbling into. So we need to watch out for those. Okay, so what can we do? So let's look at the solution and see what this person thought of. So in this case, first of all, let's remember that this is just one possible solution. Specifically, with the flexibility of regex allows for many different patterns to match the same thing. So although this is a solution, it doesn't mean that is the only solution. So let's see. So we have a PRX match where we're looking for the letter H followed by an optional letter E that can be there none or once, an optional letter A that can be there none or once, a D, and then this character that, if we remember, is a blank space character that is also optional, followed by the word ache, and has a non-case sensitive operation on it. So let's see, if we run this, what do we get? There we go. So we get it. We see that we were able to distinguish. Did not print. I did not print this. Okay, so we see in here that we were able to find pretty much all of them. So we have this one did not have a headache, but this participant did have, this patient had a headache right there with a space in between. Then this one apparently had 1, 2, right there. This one didn't, this one did right there. This one, no, no, no. And then one last headache with capitalized. So we did find that out of all the 9 patients that were intake into the ER, 4 of them presented headaches as part of their symptoms. Perfect. So we are able to do that now. Excellent. So now let's look at exercise 5 here. So right now we're going to be working with phones. So another type of scenario where you get a database is, it might be a database that you have all the information, it's just not in the right format. And you want to be able to fix that. Why is it taking time to print it? I have to load it over here. Phones, here it is. So here's a scenario, and sorry that this letter might be a little bit too small. I don't know why, just my results are not printing what I want them to print. We have phone number for participants. However, they are in all shapes and sizes regarding the format. Some of them like to use dashes to separate their phone numbers. Some of them don't do anything. Some of them use parentheses and spaces. Some of them even added the country code. So it's all a mess. And some of them are even incomplete, which is something that we might want to consider when we're going through. So then how can we take this data set and use a little bit of this regex knowledge that we have so far to make it look into something that is a bit more useful? So let's first of all start by manipulating the data set just a little bit by using the compress function. This is not regex related, just throwing you a freebie here. Where we're just going to use compress to get rid of all of the terminology except the plus sign and the numbers. And it's also going to trim the data set a little bit. So let's see if we can print that. Let's just put it in here. Phones number. I probably just forget. I forgot something. Part print phones. That is weird. I don't know. Okay, we're just gonna go ahead over here again. So this is what that compress function did. It just got rid of all those spaces, it got rid of all those dashes, and it got rid of all those parentheses. It did leave the plus sign because we want to make sure that we're taking that into consideration later on. So that is what we have now. So let's work with this and let's see how we can transform this number now into a nice format that we can use to just have nice presentable data. So that is where we're gonna go here now. So in here, now we're gonna change a little bit of what we have done so far, no pun intended, because we're gonna be looking at PRX change instead of PRX match. So PRX change, what it does is you give it a pattern and it's gonna match it, and then it's gonna substitute it with whatever you want that pattern to be substituted with. So for instance, you can give it, let's say, a random phone number that is in just a line of text, just a line of numbers, and we can find those specific matches and then transform that into a nicely formatted phone number. So let's look a little bit into the PR exchange syntax and its breakdown. So first of all, PR exchange starts with PR exchange and then parentheses, and then we start with those quotation marks to open a string, as we said in the PRX match. However, in this case, before we go into the full operation for the pattern and the target, we're going to add an operator called S, which is the substitution operator, which means that it's going to find that match and then it's going to substitute it with someone else, something else. So that S operator with PR exchange is crucial. Then we're going to feed it a pattern, as we have been doing with the PRX match so far. And then we're going to use a substitution, which is we're going to give it a format in which we want that data that it matched to be substituted. And this is going to happen also in the same syntax as PRX match, sorry, as the regex syntax. Then we're going to give it all later on an option to match however many times we want. And then we're going to give it the target string that we have given it so far at the end of that function. Okay, so let's see how that looks. So first of all, we are going to be using a little count C function just to identify how many digits we have. That way, if we know that we have less than 10 digits, in this case, 9 digits, we can just give that an incomplete and move on, because we don't want to start doing these substitution operations over incomplete data. It's gonna give us something in return, and it's not gonna be what we want, because as my coding math professor used to say, trash in, trash out. So we want to make sure that we're not putting trash in. So that's what we're doing here with this count C. Next, let's deal with that phone that had the area code, the country code in it. And that's why we left that plus symbol in there. In this case, the plus symbol, it is also a meta character. So that's why we're using the escape meta character, the backslash, to make sure that we're able to find that plus symbol. So we're going to be looking for a PRX match that has a plus symbol in it anywhere in the variable digits. And then if that is the case, then we're going to do that phone format, the new variable that we're creating, is going to be PRX change, because we're going to substitute. And this is what we're doing here. First, we're going to be matching. So this is our matching section. So we're looking, again, for the plus and then a 1, and then 3 random digits, then 3 random digits, and then 4 random digits. Big thing to notice here is that I use these parentheses. These parentheses are also meta characters. They're not going to be read as part of the string. They're read as a specific special character. And what it's telling you is that what the parentheses is telling the regex function here is that these are going to be a grouping, and we're just going to have to memorize those groupings for a little bit in the computer, because we're going to be recalling them later. So we're going to have one grouping here, one grouping here, and then one final grouping back here composed of 4 digits. And then we're going to use this / to separate the patterns string from the substitution string. And now we're going to do the substitution over on this side. And what we're going to do is everything that you match back here, I want it to be substituted with the following. Put a parenthesis in there, and then do a /1. This backward /1. This is telling, remember those groupings that we created? I want you to recall the first one that we created and placed it here. And then we're going to give it a space, and then a /2, and then a dash, and a /3. So this /2 is, again, those groupings that we created. Recall the second one, put it here. Recall the third grouping, and put it here. And let's see how that begins to look like. I did not put print here. Print data equal what's the data name, 112. And we run. There it is. So first of all, we did notice that we had this phone that was incomplete. So we put it as incomplete. And let's look at this first one here. So the match was looking, again, for this +1. And then he matched 3 digits and then made that a group. Match 3 another digits and made that a group. And then match 4 last digits and made those a groups. And then when we use the substitute function, we said parentheses, in between parentheses, put the first group, then have a space and input the second group, which is this one, and then give me a dash and import a third group. And that is exactly what it did for us. Perfect. And then in here, we did another counting function to look for those that had 10 digits. And we did the exact same thing, just without the +1 being targeted. That way, we do not get confused with that. So good so far? Any questions at this moment? All right. Very well. In that case, that is everything that I have prepared for this class. We do have one final problem that we can go through. However, this is, oh, don't look at the solution, my bad, ignore that. This is for you to practice if you want to keep going, because I do not believe we have the time to go through this problem as a whole, because it can be relatively complex. But what this is doing is now asking all of that we have learned so far, how can we use it to separate a full name into a first name and a last name? So in this case, from all the information that we have gathered, how can we take these full names that we have here in all of their different formats, and as concise as possible, which is not going to be too concise, this one is a complicated one, how can we begin to separate these into first name and last name? But I think right now we might not have enough time for that. We do have just 10 minutes left. And I wanted to just get out of here for a second. I'm going to stop sharing for a moment. And just check how everyone's feeling. Do we have any questions at this moment? Is there anything else that we'd like to discuss? Anything that was unclear? We went through a lot of syntax, which is definitely not the most easy thing to do in class. So if you have any questions, please let me know. I am here to answer.
Alejo, one question that I always like to ask is, where do you think, like, where do you usually find help when you're trying to code some of these things? Like, is there a website you usually go to?
You are way ahead of me, as always, Lala, always asking the future questions. Yes, there is. So I do have a little presentation slide here called additional resources. So these are one of my favorite pages that I use whenever I have any questions. So I can just showcase them very quickly. So first of all, this one I just found recently and I absolutely loved, which literally is a little short course, a little short lesson that you can do with active examples and like responses that you can do to see if your syntax is correct in matching what you want to match and ignoring what you want to ignore. So I found this to be extremely useful, and it goes through all of the basic operations that you want to use with rejects. And it just builds on the knowledge that you have been making before. So it is extremely useful, highly recommended. The other one is a little quick cheat sheet that I use. Let's see, and here it is. So this one is because, again, I went through a lot of syntax, and to be honest, that's what regex is. For the most part, it's all syntax. And as you can see, there is a lot of it. And then you can get into more advanced terms, such as like lazy matches and greedy matches, which might be important when you're dealing with large, heavy data sets, in which case you want to be as efficient as possible in the processing side of things. So regex is amazing for all those type of things, but they also can get extremely complicated. So that's when I come to this little cheat sheet website that I use for just to get an idea of what things are, what they mean, and what they do. So I'm just also going to add both of these here into the chat. Also, you should be able to get it from the presentation that is in the folder that Lala shared. But just to do the due diligence, I'll put it in here as well. So there's that one. Is it a link? No, why would it paste like that? That's such a weird thing. Is that going to be a link? Or is it also going to be an image? Perfect. And yes, like Lala mentioned, before you leave, just make sure you do complete the survey link. So you can get your chance to win some amazing prizes, such like an iPad, a Garmin watch, or some even AirPods. I could use some new AirPods. I'm using these wired ones, and I feel like a peasant. Just kidding. So yeah, make sure you complete that survey and mark your attendance. And if you have any more questions, we do still have some time.
Thank you so much, Alejo, for presenting today. That was really awesome. And now I'm going to come to ask you for help whenever I'm doing it myself.
Perfect. That's what I'm here for.
Alejo, te están saludando.
Okay. Oh, no veo las cámaras.
Oh, he's not on camera. He can't see you.
Hi.
Did you stop recording?
Yes. Awesome.
Thank you, Alejo.
Of
This was
course.
awesome.
Thank you all for bearing with me. I know it's always difficult to go through so much content.
Oh, no, it was great. I loved it. Thank you so much.